Krishna sir, can we start, sir?
Yeah, Shashank sir, yeah.
Okay. Yeah, okay, sir. Thank you, sir. Good afternoon, all. Welcome to the second session of the day 4 FTP on blockchain demystified. So we have with us Krishna Suri sir, who delivered a lecture yesterday. So this is in continuation with the previous discussion, and he'll focus will be on Hyperledger Fabric as well as the demonstration. Okay, over to you, sir.
Thank you. Thanks a lot. So we can start now, right? So we are at 2:30. So
Yes, sir.
we will have, yeah, yes, sir. Thanks for the introduction. And in continuation with yesterday, whatever we have discussed, some of the fundamentals that are very specific to everything, right? It is public blockchains and private blockchains, not specific to any specific blockchain platform or solution as such. But today we will be looking into more focused details like Hyperledger Fabric, which is a private and permissioned blockchain network from Linux Foundation, right? So this specific details actually we will be going into more deeper, and I wanted to provide you how I am going to organize the talk. So we will have two sessions now. One is the first session is about 1 hour 15 minutes, where we will go into different theoretical aspects and how the protocol works and other details of the Hyperledger Fabric platform. And in the second session, we will have a 15 minutes break following that. Then in the second session, which will be our 1 hour a lab session, I will be providing you how to set up details about how to set up a basic Hyperledger Fabric network and perform some invoke query operations on the ledger. So this is the overall objective or goal. So let me start with some of the recap. Yesterday, most of this stuff we have seen. Business networks actually connect businesses, and each participant in the network needs an identity. We will see more details about identity and other aspects now. And assets flow on the business networks means assets actually which are represented in digital format are owned by different owners, and as part of the transactions getting executed, the ownership of the assets may change from one owner to another owner, which is known as assets being flown on the business network. And transactions describe the asset exchanges and how the transactions are encoded in any blockchain network. Yesterday we have, if we can recap, smart contracts are used to encode the transaction execution logic, right? So the same thing holds good with the Hyperledger Fabric also. And let us go through some more specific details about Hyperledger Fabric, the protocol, and some of the architectural components. The first, these are all the different architectural components of Hyperledger Fabric. This is the permissioned blockchain network. Here, the first and foremost important component is ordering service. So this component actually is responsible for packing the transactions into different blocks and cutting blocks in an order. So this is the module which is responsible of doing that. And then we have some peers in the network, which are all the participants of the blockchain network. And these peers, they can hold different roles. One of the roles is endorsing role, another is committing role. Endorser role means that they are the peers which will be executing the transaction. So somebody needs to execute the transaction by considering some inputs, and at the end of the execution, they will generate some outputs. So the outputs will be written to the ledger, and that contributes to the blockchain state, right? So that somebody who is executing is known as endorser, and it is in Hyperledger Fabric, not everybody participating in the network won't be executing the transaction. Only certain individuals with a specific role, identified role called endorser for a specific channel will be doing this activity. And committers are The rest of the peers, which are part of the network, are known as committers. So what they do is that any transaction that is part of a block, when they receive a block, they will process the block and take each transaction and apply the write set onto the state database, and also add the block to the blockchain locally available with them. So these are the two steps are done by any committer. So next is ledger. This is the blockchain chain of blocks. Here you can see. Okay, so ledger is the blockchain. This is the chain of blocks, and then chain code. So this is the smart contract. Then events at the end of execution of the transaction, there can be certain events generated to which the clients are subscribed, so that they can come to know that when a transaction execution gets finished, and they can even check whether the transaction is success or failure, because it's not guaranteed that a transaction is always succeeding just because it is part of a block. Even though a transaction is a part of a block, it may fail or it may succeed. So that depends on certain conditions that we will see. And these are the admins who are the administrators of the peer, each node or the peer, that is the participant of the network. And there are certain things called Fabric CA membership services, which we will see in detail later on. And this is the client application or the client. This is one important component because clients are the individuals who submit the transactions to the network. So if the clients are not there, nobody is going to submit any transaction to the network. So it is one of the very important component. They also have associated MSPs. We will see the details of MSPs and identities in the following slides. How the application interacts with the ledger. If you consider any blockchain developer, what the developer will do, he will need to develop two components. One is the client application, the application logic he needs to develop. It can be a Java language or in a Go language. The the developer is developing this code. The second part is the encoding the transaction logic as part of the smart contract. So the smart contract is sitting on the blockchain, and whereas the client application is outside of the blockchain network, and the communication between the client application and smart contract happens over the SDK, that is with the client application. So through the client SDK, the client submits any transaction. It can be a query transaction, it can be a invoke transaction. Invoke transaction again can be two types. One is delete, or another is put. Query is the get transaction. So in case of a query transaction, when it is executed, by looking at the world state, so which is the key value stored in Hyperledger Fabric, the queries are responded. So in case of put and delete transactions, uh, there is a impact on both the ledger as well as the world state. So we'll see more details, but at the end of the transaction execution, some events are emitted, and those will be consumed by the appropriate clients, whoever is interested. So this is the bigger component is the peer. So each peer in the network consists of these modules. So one is the ledger. So ledger is consisting of two parts. One is the blockchain, that is the list of blocks in a chain. So this is the blockchain, and there is a world state. So this world state is an optional component which is introduced in Hyperledger Fabric to improve the throughput, right? Transaction throughput. How it is helpful is that it is though it is an optional component, it will help a lot in achieving high throughput rates. How it will be helpful is this keeps track of for each key what is the recent value, so that any query that comes on a key, right, it can be directly answered by referring to this world state database. So if it is not there, ideally what we would end up doing is that we need to iterate through all these transactions in the blocks starting from the recent block and see how the value of a key is getting impacted, right? So that is very costly operation. So to circumvent that, we have this world state. So the next component is Fabric Ledger. as I already told, there are two components. One is the world state and the blockchain. This is the blockchain, and here we maintain the hash of previous block in the header of the current block. Yesterday we were explaining that, and this world state can be implemented either as a simple key value store called level DB. So this is just a library which will be used to access the data inside the world state. And there can be, or there is an alternate option is it can be implemented as a couch DB, which is a sophisticated database which can be used to support indexing along with the keys, so that your query performance, you can execute complex queries. Like I want to fetch all the student records with the average marks between 80% and 90%, for example. Such kind of query I want to execute, then it is not possible to execute such queries using level DB, whereas using couch DB, you can technically implement any kind of database query to fetch the data, right? So this is on another variant which is kind of advanced, and each transaction in the block in the Hyperledger fabric consists of two important components. One is read set and the other is write set. What you mean by read set is that what are the variables we are using, referring, and write set is what are the variables uh, we are writing, right? So these are all the two read sets and write sets. So for example, going back to the example that yesterday we were considering, transferring some X amount from account A to account B. Now assume that you cannot take out entire amount from account A. There has to be some minimum account balance. So that account balance is, so let us say you refer it with a variable C. Now in this transaction, when you are implementing, you access three different variables, right? In fact, account A, account B, and minimum balance, that is value C, that is another variable. And what you do, you subtract, you are transferring amount X, so you subtract amount X from A, so A minus X you do, then you add that amount X to the account B, so you perform B plus X. At the same time, while before doing this, you will do typically two checks, whether the current balance is greater than or equal to X, A is greater than or to X, that is one check you will do. The second one is after you deduct this amount, whether you are still maintaining some minimum balance that is mandated from the bank side, right? So that amount is C. So what you need to do, A minus X should be greater than or equal to C. This check also you will do. Now in this entire process, if you consider C, that is the minimum balance amount, we are not at all updating. We are just referring that amount and doing our implementation of the transaction. So in this case, C is termed as the read set, whereas account A and B both appear both in the read set and write set, because you are accessing the values of accounts A and B, and at the end you are updating the account balances. You are subtracting X amount from A, you are adding X amount to B. So the account balances get updated also. So they become the write set. So this is for this specific transaction amount transfer. The read set is A, B, and C. The write set is A and B, and X is the parameter, input parameter to the transaction, right? So this is, if you understand this, you can correlate with the different flows we have, right? So this is very important to understand. So more into the details of different components of the Hyperledger Fabric network. So essentially, this can be implemented. You can always assume that whatever the transaction that I explained, you can assume that you can implement using a centralized database also, right? The only difference being now you want to do it in a distributed environment, so that you provide all the guarantees that blockchain is guaranteeing us. So that is the only difference. So your execution logic of the transaction is essentially going to be the same. Only thing is that the environment in which it is executing is different. So now the peer. So the peer, as I said, it has many different roles. It can be ordering peer, it can be endorsing peer, it can be committing peer in a Hyperledger Fabric environment. Endorsing peers are, these are the specialized peers, as I said, which can execute the transaction and compute the read rate sets. And the ordering service node, this is again the specific node or service which actually packs the transactions into blocks and cuts the blocks, disseminates the blocks to all the participants of the network. And then Hyperledger Fabric actually follows a specific consensus mechanism called endorse, order, validate. So this is very important to understand. This specific architecture, endorse, order, and execute, it's a three-phase architecture. There is phase one, phase two, and phase three. This is very much different from any public blockchain architectures where the typical architecture is order and execute. So this is endorse or execute. You can say anything. Execute, order, validate, or uh, this is a in contrast to the public blockchain architectures, which is order and execute. So in order and execute public blockchains, what happens is that first the transactions are grouped into one block. So that is the mining process. If you recall from yesterday's call, then once the block is mined and added to the blockchain, then everybody have access to, every participant in the blockchain network has access to this updated chain. Hence what they do, they take this recently added block, execute the transactions, and update their local state variables as per the transaction execution logic. So that everybody does it. And in this process, one very important thing to note is that the execution logic is deterministic in nature, which means that either party A executes or party B executes the transaction, it produces the same output. That is the inherent assumption when we are dealing with the transactions with in blockchain. So having said that, there are certain limitations and advantages, both pros and cons, but we will not go deeper into why that specific architectural paradigm is adapted by public blockchains. But in case of Hyperledger Fabric, it is execute, order, validate. This helps in the following sense, because execute is happening before order. There is something called transaction concurrency is achieved, because not every peer can need to execute the transaction. We can actually associate certain peers to execute the transactions coming onto certain channels, so that in parallel the endorsing peers that belong to different organizations can be executing different transactions, hence your throughput can be increased. So this is one of the design principles to have this three-phase approach. And once the transactions are executed and the rate sets are computed, this all will information, entire information will be packaged in the transaction proposal and given to the ordering service, where the ordering service cuts the blocks. And once this is done, at the end, while committing, before committing, right, the committing page, they cannot simply take whatever is the right set passed. They will do a validation. They will check whether the right set for a given transaction is the appropriate right set given the read set is fixed. So they will do this validation, and only if that validation passes, the transaction is deemed to be succeeding. Otherwise, the transaction will be marked as failed. So this is where I said a transaction, even though it gets included in the block, may get failed or may get succeeded. So this is all depending on the result of the validation phase. So let's dive a little bit deeper into, because this is one of the core of Hyperledger Fabric transaction execution processes. So that's why let us go more into details of what are the different steps and which specific player performs what step. So before dwelling deep, just to recap, we have these different roles. One is the endorser. So we represent them with the blue box, and here in this specific channel we have, by the way, channel is just you assume that a logical network, there can be many different channels because we have many different networks, right? I interact with you consider your WhatsApp groups. You have so many groups, your family group, your friends group, your office colleagues group. So many groups are there, and the discussions that you carry out in each group is different. And you want typically to segregate these discussions, right? You don't want to put some family discussion onto your friends group and so on. So similarly, so there is, these are the logical partitions. So exactly similar to that, in Hyperledger Fabric we have something called channel. So each channel represents one logical partition of the participants. So the participating users will be transacting inside the channel within that channel's context. If there is a different channel, then the transactions submitted will be different. So the context is different, right? So consider one channel where you have the participants, right? Now, in any channel, these roles are common. Any channel will have an orderer. Any channel will have endorsing peers and committing peers and all these roles. So endorsing peers are the peers which will be executing. Here we have in this channel three endorsing peers, E0, E1, E2, and we have the smart contracts, two smart contracts. So the two transaction types are possible. Each smart contract you can refer to as one transaction type. So for example, the transaction debit, it can be one type of transaction, and there can be another different type of transaction associated with the chain code B. So similarly, in fact, there are more chain codes here. There is another chain code called D, type D, and this endorsing policy, I will talk about this later. Then ordering node. So this is ordering service. Because it is a ordering service, we want this because this is the core of Hyperledger Fabric protocol. So we want to have high availability for this service. Hence, typically you deploy odd number of nodes as part of this service and ensure that the service is always up. So then, by the way, any number of nodes can be used. So committing peer, the committing peers, as I said, only maintains the ledger. They do not actually execute the transactions or not even want to submit new transactions also. They can, of course, submit new transactions. And then application, this is the client application which is submitting the transactions, and it can be associated with any peer. And then endorsers and ledger, all these components are now familiar. So the first step that happens is that transaction is proposed by a client. So the client creates a new transaction and it sends it to all the endorsing peers individually. In a peer-to-peer communication, it sends. It needs to know who are all my endorsers in this channel. So the client application needs to know. So it has a specific process. It will go through that process and identify, comes to know that, okay, these are the peers which are endorsing peers of this channel. Hence, let me send this transaction proposal to these peers. It does that. Then the endorsing peers, they execute the transaction that they received from the client. So this is the second step. They execute it and they create read write sets. And once they create the read write set, what they do, they prepare the transaction response, the request response, transaction proposal request response. As part of the response, they will include the read set, they will include the write set, and they will digitally sign that information and send it back. So that is the second step done by each. The same thing is executed by each endorsing peer. And then the third step is uh, proposal. Can you please give me 1 minute? Yes, but I'm in a meeting. I'm in a meeting. Can I call you back after some time? Okay, sure. Thank you. Okay, so I'm sorry, I'm back. So the third step is the proposal response. So they create the response and digitally sign the response. They will package that into one payload as part of the response and send it back to the client. The fourth step is the client. What it does is that it receives the response from each of the peers, right? It does first a validation. In the validation process, it does two things. One is, did I receive the endorsements properly as per the endorsement policy or not? So the endorsement policy, it can say that even though I have three endorsers, I don't need to collect the endorsement from all three of them mandatorily. So that's what is defined by endorsement policy. It can tell that, okay, collect the endorsement either from E0 or from E1 or from E2. That can be a different endorsement policy. And a different option could be collect from both E0 and E1 mandatorily. E2 can be optional. So likewise, there are many different ways the endorsement policy can be specified. And as per that specification, it will collect the endorsements. So then it will check whether I have received, because it sends a transaction proposal, and due to some reason the endorsing peer is not available, it endorsing peer may not send the response, right? So it is not always guaranteed that the client will receive back the response. So it has to verify all the responses whether they are consistent with what is needed. So the need is that which is specified in the endorsement policy. So whether the endorsements did I receive appropriately as per the specification in the endorsement policy or not. This it will check first. Second one is very important criteria. The endorsements that it receives must be matching, because it is the same transaction and the same inputs are used, the output should be the same. If the endorsers respond with different outputs, then it cannot proceed. So what it does, it has no option but discard all these endorsements and resend the requests to all the endorsing peers. But because it doesn't know who is the culprit, who is misbehaving, right? So it has to discard all these results and resubmit transaction and repeat this process till it receives all the endorsements are same. Once all the endorsements are same, then it creates one transaction message. The transaction message consists of the following things. One is uh, one of the endorsement, that is read and write side, and signature from all these peers, endorsing peers. Everybody will be signing, right? All their signatures, and uh, uh, it just submits that information. The read write sets and the transaction detail, also transaction information, what is transaction ID type and so on, and then the signatures from each of these endorsing peers. All that it will bundle and send it to the ordering service. If there are multiple ordering nodes, it will send to each of the ordering nodes because it knows that information. So there is a way for it to come to know about this information. This identifies that information and sends it. The next step is the ordering service. It is collecting the transaction messages, not just this client, right? There may be many different clients that are communicating with our blockchain network. So it collects the transaction proposal messages from different clients and decides which ones to be included in the block and creates a block. That is called cutting the block, and once it creates the block, new block, this is the new block, it disseminates the block to all the peers. Again, ordering service knows that who are all the channel members. Only to those channel members it will send this information, disseminates the information. So this is the next step. So deliver the transaction. So one thing to note here is that the ordering service that is used in Hyperledger Fabric is pluggable in nature. It is Hyperledger Fabric itself follows something called modular architecture paradigm. So the different components that we use in this entire solution architecture are modular in nature, which means that you can plug and play with the alternate solution also. Is there any query? Hello? Okay. So and the different ordering algorithms available are, there is something called solo, which means that there is only one ordering service and it does the ordering, and there is Apache Kafka based CFT crash fault tolerant ordering service, right? So this is just one variant. There can be many other sophisticated solutions also can be plugged in here as the ordering service. So that's to be noted. And once the blocks, in the previous step, we have seen that the blocks are received, the newly created block is disseminated to all the members of the network. So once the block is received, what they do, each peer, it will add the block to the blockchain. You can see here that block which was passed here to all the peers, they add it to the local blockchain. This is the to the infant. So to the top they will add it, and they will execute the transactions in the block. So before doing that, each peer also does this validation. So this validation mechanism in Hyperledger Fabric is called VSCC mechanism. So what they do, two things. again they kind of do a repetition of what client did. Whether the endorsements are hello, yeah, I'm in a meeting. Sorry. Okay, I'm sorry. So this one, yeah, so each peer does the validation, which is kind of repetition of what client applications does. So what it does, again, it will check whether the endorsement policy is proper, the endorsements are collected from appropriate endorsing peers for this channel or not. That is verified once. The second one is whether the endorsements are same. So it doesn't need to do this because as you remember, the client application sends only one single endorsement. So it won't check whether the endorsements are same. It will assume that they are all same. Only thing it does is that whether the signatures are proper or not and endorsement policy is correct or not. On top of these two, it does one additional check called MVCC validation, multi-version concurrency control. So just to recollect back yesterday, what we uh, discussed is that any ledger transaction, right? There is this problem of double spending, right? So you need to ensure that any blockchain platform need to ensure that double spending doesn't occur. So this is ensured in Hyperledger Fabric during the validation phase in the MVCC mechanism. So in the MVCC, typically what we do is we check the versions of different read write sets are proper or not. Any double spending is not happening or not. It will check and ensure. Yesterday we covered this, so I am not going into details of how the specific check is carried out. But MVCC is used to eliminate double spending, and only if the transaction is proper transaction, it is not double spend transaction. So then only it will be committed and accepted. So that is the last step. So once the transaction is accepted, as I said, a event can be generated by the peers, and those events can be consumed by the clients. And clients can now verify whether the transaction that I submitted is a success or not. It will verify it. So it has all the details now inside the event. So it will appropriately parse the event and come to know whether the transaction is success or not. And if it is success, what is the transaction output and so on. So all the details it will come to know. So this is the different steps in the transaction execution process. We will see the same thing with the help of one swimline sequence diagram. So here you see I am representing the endorsing pairs here, and this is the client, this is the ordering service, and these are all the committing pairs. So if you go back to this picture, we have the ordering service, endorsing pairs, committing pairs, and the client. So these are all the different roles. So we have represented everybody. The first step is client is creating the transaction proposal, right? So it is submitting the transaction proposal to the only to the endorsing peers simultaneously. So this is the first step. Just to recap whatever we did, and then the each endorsing peer they does repeat the same thing. That is, they execute the transaction and compute the read write sets. Once they compute, they create the transaction proposal response and send back to the client. The client in the next it receives the responses from the different endorsing peers and does validation, which I said the whether the endorsement policy is proper and also endorsements are equal or not. It does that validation, and then it will create the transaction message, which includes just the one set of read set, one set of write set, and the digital signature of all the endorsing peers, and it sends that to the client ordering service. So this is the third step. Once ordering service receives likewise transaction messages from different clients, they create the blocks, and the newly created blocks are disseminated to all the peers. When we say all the peers, the committing peers also come into picture. And once the blocks are disseminated, the validation is common across any peer, whether it is endorsing peer or committing peer, which is part of the blockchain network. They perform the same steps, and which includes VSCC validation and MVCC validation. That is whether the transaction is proper or not, and then MVCC is whether it is a double spend transaction or not. If both the transactions verification processes pass, only then it is committed to the ledger. So this is the summary of what happens. So this is the life cycle of transaction in Fabric. Now let us see. Um, just one thing to recap is that so this life cycle is specific to any transaction of type delete or update or insert, right? So if you refer back, there are three kinds of transactions we can see: get, put, and delete. So put and delete, they go through all these phases of life cycle. In case of get transactions, if you can think of, it is not required to execute steps 3, 4 here. Once the client submits the transaction proposal, all the endorsing peers respond. Then the client, by looking at the responses, can come to know what is the my query response. So there itself it will stop. It doesn't include the query transactions in the blocks. So that is very important to note. Here itself it can stop. And also one important thing is that it is not necessary for the client to send the query to all the endorsing peers also. It can send to selectively to specific peer or set of peers and collect the responses, do validation, consume that. It can do that. So little bit more into ordering service. As we said, ordering service, we have different options. One is solo, the second one is Kafka. Solo means we have only single node. Typically, this is not a suggested configuration for production environments. In production, actually, we need to have sophisticated ordering service mechanisms like Apache Kafka ordering service. This is one of the well used accepted ordering service mechanism. So it implements crash fault tolerant consensus mechanism internally, and you can deploy this with minimum 3 nodes to 5 nodes to 7 nodes, and odd number of nodes is preferred. So this is one of the things. And the channels, the ordering service, it can be part of one specific channel or multiple channels, because ordering service doesn't cache or refer to the details of any transaction. It is trusted party. It doesn't actually care about who is the transaction submitter or what is the specific transaction is about, or what are the read sets, what are the write sets. It doesn't care about. So, and also it won't even cache any details data related to any channel. So that's the reason typically what we configure is that we have single ordering service which is used across multiple channels. Of course, this ordering service itself is having node redundancy, right? So it can cater to any amount of load also. There is no concept of ordering service getting overloaded, right? Because we have so many peers in the network. So for one channel, red channel, this ordering service node might be the master node, and it may be syncing the blocks in coordination with the other nodes in the ordering service and communicating to the peers of this channel. Whereas for a different channel, there is something called a anchor or master, right? So a different ordering node can be the master for a different channel. So that's how you can scale the ordering service to any extent, so that you will ensure that ordering service is never the bottleneck for your performance. So that much guarantee we can give. And what is additional points? Each peer can be participating in multiple channels. Going back to my example, you have multiple WhatsApp groups. So similar way, any peer can be participating in a different number of channels. And the chain code is installed on peers to access the world state. And chain code is instantiated only on specific channels. What is installation, what is instantiation, we will see. Only when instantiation is done for the chain code, then you can execute, you can be the endorser for that channel. If a chain code is not instantiated, uh, you being a peer cannot be endorser for a given channel. You can still be committing peer, but you cannot be endorsing peer. So this is one requirement. So let us see an example of a single channel network. Uh, so in this, as we saw, as is it falls under the single channel network where we have one channel and we have one blockchain. Just remember the fact that the ledger is specific to a channel. So when I say a single channel, then you have only one ledger. Every peer will be having access to only one ledger. But at the same time, there can be multiple chain codes. Even though you have one ledger, there can be multiple chain codes. So each chain code actually is nothing but different types of transactions, right? So in your ledger, you can have different types of transactions. For example, if you take in a banking system, your ledger will have deposit transactions, fixed deposits, fund transfers, NEFT transactions, withdrawals, and so on. Many different types of transactions are there. So you can assume that each type of transaction is implemented as part of one chain code. Hence, you have many different chain codes. It is A and B here. These are the chain codes with the same ledger, right? So, and the ledgers are with the peers, either it can be endorsing peer or committing peer. So here in this example, all the peers are endorsing peers. There is nothing that can stop us making all the peers are endorsing peers. So multi-channel network here, the peers E0 and E3 are part of two channels. That is the red channel also. I mean, E0 is part of red channel, E3 is part of two channels, the red channel and the blue channel, whereas E2 and E1 are only part of blue channel. So if you can see, only E3 is participating both the channels. All the other endorsing pairs are participating in one of the channels only. And your chain codes are channel specific, right? So because each channel is consisting of different types of transactions, the chain codes are specific to channel. So in the red channel here, we have chain codes Y and G. In the blue channel here, we have chain codes A and B. And we can have many different clients communicating to the same peer or different peers. So here one client is communicating to this peer E0, which is on the red channel. Another peer client is communicating to E1, which is on blue channel. So it is also possible that the same client is communicating with both the channels also. Nothing prevents. So as long as it has the proper identity, the same thing is tracked as part of something called MSP that we will see, it is allowed. Next is fabric pair. Each pair has in more detail these different components. Pair is associated with channels. So that means that you owning a pair, you can be having multi participation into multiple channels. You will be discussing in multiple different networks. Here we have blue, red, and green, three different types of networks. And a pair will have access to different types of chain codes, many different types of transactions you will be performing, right? So you can have access to many different types of chain codes. Then you have a local ledger, one for channel. So that's why if you see, we have three ledgers here. One is blue ledger, another is below it a red ledger, and further below you have a green ledger. Each ledger will contain the two components, oral state and blockchain. And each peer has a local MSP. We will see the details, but local MSP will help us identify which are all the users who can be acting as administrators, or who can access this peer, or who can even a client, right? If it is submitting a transaction to a channel, it has to have a proper MSP. It needs to be a member as agreed by the network. Any random client cannot submit a transaction. That's what is we mentioned the permission network. So permission is two scenarios. One is the membership, channel membership is also permissioned. Nobody can join the network unless you have a permission. So it is a permission network. Second thing is any random person cannot be submitting transactions into this network. That is also permissioned. So only appropriate people with a valid identity only they can submit the transactions. So that which is tracked using MSP. The next one is client application. As I said, client application has typically two components. One is the application logic itself, which is developed either in the Go or Java kind of languages. And there is SDK, the SDK software development kit that is useful to communicate with the your chain code on the peer. So this is the communication mechanism interface. And then again with the client, we have access to local MSP. Why this MSP is used? Again, it will be helpful to define who are all the channel members, who are all the endorsers of my channel. So that information is kept in the local MSP, which will be helping the client to know to whom I need to communicate with. So the fabric CA. So let me go over the CA details a little bit deeper. So this is very important to understand what is identity and what is MSP, because these are all the two important components in the process of configuring any blockchain network. Otherwise, you don't have control on your network. So you need to understand the fact that if you want to have control, you need to appropriately configure these two entities with any peer or organization or any person joining the network. So what is an identity? Each participant on Fabric network has a digital identity encapsulated in a X509 digital certificate format. So identity is nothing but it is a digital certificate. So it provides you that it is you. It's similar to your Aadhaar card for individuals. For network members, this is the Aadhaar card. Then how do you get it? There is a system called public key infrastructure, and you communicate with this system and get your identity. So how it works? A peer is coming. This peer needs the identity. So first, the peer communicates with the certificate authority. So this is the approved authority, and it sends a request. The certificate authority issues a certificate to the peer. The certificate is nothing but the digital certificate. Along with this, it has access to a public key and private key. So it is very important for the peer uh, to keep the private key confidential. If the private key is lost, then anybody can misuse this digital certificate on behalf of this peer. So it is very important. So if the public key is anybody, everybody knows it, right? So when I am using this for signing my messages, they will come to know that by looking at this private public key, it is me who has signed this message. So this is known to everybody, and private key is very very much confidential to me. Only I should be able to have access to. If this is compromised, then my integrity is lost. So this is very confidential. So this is the workflow, how one is achieving the digital certificate. Now, having said that, remember the fact that if your private key is compromised, then you need to report it to the certificate authority, and they will include this certificate in something called certificate revocation list, CRL. So when they, because this is, even though the certificate is the private key is known to somebody else, so that means the privacy of the private key is lost, still it will work. It can be used for signing. Only thing is that it is not just you, anybody can sign it. That's the only difference, because you, it is compromised, somebody else also can. It's like your email account is there, you lost your password and password is known to your friend or somebody, then they can also start sending emails on your behalf. That account is not invalid, right? It is still a valid account. Only thing, it's not just you, but somebody else also can operate that account. Ideally you don't want to do have to do that, right? You want to operate your account on your own only. So you don't want to reveal your password to your email account. It is exactly the same way. If you lose your private key, somebody else also can participate operate that account. So what you need to do at that moment, you have to report it to the certificate authority, saying that okay, my private key is compromised, hence they will include something called in the revocation list, CRL. So then what happens, whenever the intruder, whoever has access to your private key and trying to mimic you, then they send any message or anything that gets any message comes to the certificate authority for verification whether this private public key pair is valid or not. At that time, this certificate authority will refer to this CRL list. If this certificate is included in the CRL, then they will disapprove that request. So that's how you can protect yourself. If you if your digital certificate is compromised, your private key is revealed, you just need to immediately make it to the note of CA, who will include the CRL. Hence, nobody else can use that for mal purpose. So that is very important. The next one is the digital certificate. So by the way, in the PK infrastructure, we have these four components: digital certificates, public private keys, certificate authorities, and CRL. We have seen all the components here. Let's look into a little bit more details. What is a digital certificate? It looks like in this current format, like it has something called, one important line is subject line. It specifies that who is the owner, right? Owner, and this is the owner, and where is the location, and where is the location, full address like country and the state, other information they can include in the digital certificate. Along with that, what is the organization unit, OU, they will specify, and then the the UID, also some other additional information. But this is the typical information, which is not just this information, it can include any other information. Basically, it will define who is the owner of this digital certificate with all the appropriate details, and also the public key, and the private key is communicated to you separately. So the public key, so this is revealed to everybody. So once anybody comes to know, see this certificate, they will know that the owner is this specific individual. So if somebody else is operating this, then that means that the digital certificate is compromised. Now public key and private key, how it will work. Consider that this specific individual is the owner of the digital certificate, and Mary has public key and private key, both the pairs. This is the Mary's original document. Mary wants to send a document to verifier V. So if Mary sends the document in the as is without any digital signature, the problem is somebody else on the network can change the content of this message. So that is the threat. So you want to ensure that you sign on the message digitally, so that nobody else can change it. That is one thing. Second thing is, even the verifier receiving party will know that I received the certificate or a document from Mary only. So this is providing two information, dual information. One is whether the source is authentic source or not. That's first information. Second is, during the message transmission, nobody else is tampering this message. Two things were guaranteeing. So what Mary does, she takes the document using the private key. She does the signature. So this is the signature. Now the verifier, he receives it, and using the public key, he validates the signature. So the signature valid means that document is not tampered, and only Mary has sent it. He will accept and use it. In case if document is tampered, for example, in between something is 7 cars, 7 cats is changed to 8 cats. Somebody changed it to the number. Then automatically the digital signature will get changed. Then when using the public key, the verifier is verifying, the signature will match, will fail. Hence, he will come to know that, okay, so this is not the message what Mary has sent. Somebody has tampered it. So he will discard this message. So this is the how it is working. So digital signatures are used to authenticate the messages, and they do this signature, and how this is how it is used. There is something called certificate authority that we already have seen, and the certificate authorities, they issue the digital certificates in the format called X509 standard, which is the global standard accepted, and to each individual they will create the certificates. So you can now understand that for each um, party, a certificate has to be generated. Corresponding public key and private key needs to be generated and communicated to the party, right? So this has to be done to each of the pages. So that means that there is a lot of overhead on the certificate authority. So one certificate authority cannot cater to the requirements of everybody, right? So that's why there is something called chain of trust or root certificate authorities and intermediate CAs. So what they do is that instead of having one CA to cater to the demand of all the different participants, what we do is we can have a hierarchy of certificate authorities. So the root certificate authority can still be issuing some certificate, and root can also issue a certificate to a intermediate certificate authority. So given that I am having the license to issue my own certificates, I can start issuing certificates to whoever approaches me. So I am I am holding the root certificate authority's signature, um, one certificate. Using that, I can start issuing. So this, and similarly, I can even spawn many other intermediate CAs. This intermediate CA can also spawn another intermediate CA. So this is how there is a chain of certificate authorities that can be spawned across, and individuals can reach out to any of the certificate authorities and get their identities. So this is how the load on the network can be distributed. So in such an environment, if you see the ID that is collected by, for example, CA11 here, this is the ID issued by CA11, certificate 11, authority 11. If you see this ID, one very important thing is that it needs to have one root CA signature for sure. That's mandatory. And it can have 0 or more intermediate CA signatures. So that means that one root CA signature is mandatory, even though I'm getting the digital certificate issued from intermediate CA, my digital certificate will contain the signature of the root CA as well as any number of intermediate CAs till this chain. So that is very important to know. And yeah, the next is certificate revocation lists. This, as we already have seen, right? So when the private key is compromised, so this any person impersonating on your identity, they will use the digital signature for a wrong purpose. So they are signing some message which you don't intend to do it. Then verifier is receiving that message. The verifier will always reach out to the certificate authority whether the signature is correct or not. If you see here in this step, we are doing a verification process. In this verification, actually, you will reach out to this CA internally. So what it does is that when it reaches out to the CA, it will compare whether this certificate is part of revocation list. If it is a part of revocation, validation fails. And there is something called expired certificates also. This is another concept. So any certificate is issued to individual is not a lifetime certificate. For example, your passport is one kind of certificate, right? Is even passport is not lifetime. You have to renew it every 10 years. Likewise, your voter ID, right? So every certificate has a lifetime. So similarly, digital certificates does have lifetime. So they do expire even if you are keeping your certificate secure. Then you have to renew the certificate. So any certificate that is part of the revocation list is not is still a valid certificate. Please keep in mind, because if it is not a valid certificate, then you don't need to maintain it in the CRL. You can just ignore it. Anyway, the validation will fail because it is already expired. So you don't need to worry. So the CRL will maintain only the valid certificates, and expired certificates are different. Next is what is MSP. So till now we have I didn't come across the concepts related to acquiring a identity. For example, your Aadhaar card or your driving license or your passport. You assume that these are all different identities, right? You can acquire. Now, what this MSP does is that just because I have a valid identity, I cannot do everything, right? So, so I need to have something called proper authentication to perform a specific activity. So I will take one simple example that you have. uh, two different types of credit cards. One is Visa and one is Master. And you are visiting a grocery shop where you are buying and you want to use your credit card, but the shop only accepts Amex card, for example. Then even though you are a valid owner of two different types of cards, Amex card and Visa card, still you are in a position not to exercise that transaction because that shop itself is not accepting. They only accept valid Amex cards. And if you don't have MX card, you cannot use your credit card in that shop. So it is exactly the same way. Even though you have an identity, it is not just sufficient to participate in a network. In the network, you have to be part of MSP. Only if you are recognized member in the membership service provider. This is a component in the fabric. Fabric decides that who are all the uh, recognized members of my network. So if you are one of the recognized member, only then you can participate in the network. So you need to have two things. One is you need to have valid identity and use that identity to register appropriately in the MSP, and hence you have access to the fabric network. So this is a very important aspect to understand. Now MSPs, having said that, MSP can be maintained at two levels. One is local MSPs, another is channel MSPs. So in the previous examples, wherever we have seen the MSPs, for example, here with the peer, we have seen an MSP, it is a local MSP. So similarly with the client, we have seen MSP, it is again a local MSP, right? So these are all examples of local MSPs. We will see example of global MSP, what it is. So it is nothing but any MSP, membership service provider, that is maintained at the channel level is called global MSP. So consider this example. Uh, in this is your channel, and in the channel you have one ordering service and one peer minimum. If without ordering service, your channel cannot operate because the ordering service is creating the blocks, right? So you need to have at least one orderer part of your channel and one or more peers. Now each peer has a local MSP. For example, this peer has a local MSP, and similarly this order has a local MSP. The MSP is associated again with an ARG. So this is ARG1 MSP, this is ARG2 MSP, and MSP verifies to identity, right? That is certificate authority, root certificate authority. So here ARG1 is using the certificates from uh, RCA1, root certificate authority 1. So whichever is the identity issued by RCA1, the ARG1 can accept. If you have a valid certificate from RCA2, that is not accepted by your ARG1 MSP. It can only accept RCA1 issued identities. So that is one part. Second part is your local MSP users is using in this specific configuration identities from RCA2. That is second part. Third part is you have something called global MSP. So global MSP means um, this is not tied to any peer. This is at the channel level. For example, here the channel level order service is using this MSP, hence this is called global MSP. And whereas this is the specific MSP membership service provider is associated with this peer, hence it is called local MSP. Any entity in the blockchain network will be associated with one of these MSPs. It can be global MSP or local MSP based on the role, but one MSP association is mandatory. Only then that entity can come to know whenever it is that entity is communicating with any other entity, whether I am communicating with a authentic appropriate user on this channel or not. It will come to know about that. So that's the reason MSP is a mandatory thing. Next, how do you register with the MSP? You have already an identity. So first you acquire as a there is some CLI. These different components are all, by the way, are part of Fabric network. Whenever you are onboarding Fabric network, you do all these things. What you do first, you will use your organization unit or department information, that is your affiliation information, and what role you want to have access to the Fabric network. Whether you want to have a peer network role or client network role or orderer or admin. These are the different instances types of your roles when you are participating in a hybrid ledger Fabric network. You can be a peer, a client, orderer, and admin. Admin is for peer, and peer is there can be any number of peers in the network. The client, again, a client can be participating in one channel or multiple channels, right? So these are all now well-known concepts for us. And orderer is again there can be one ordering node or multiple ordering nodes, which is contributing to the ordering service, right? So once you get the CA, and then we enroll that user with the CA. So MSP is a component, as I said, will maintain this information. What are all my certificate authority certificates? So I am registering myself as a peer, for example. Then um, my certificate will be part of peer admin certificate. So this is not a full list here, but I will be included. The ID of my certificate will be included in the MSB as part of the admins. So that I can act as the admin of that specific peer. So we'll see the details of each of these components in the next slide. But there is a two-step process. One is you need to acquire the identity. The second thing is once you have the identity using the CA, you will enroll with the MSP. This is a two-step process. So without identity, you can't achieve this. And if you don't do step two, even though you have identity, there is no use. So it is both are complementary steps. Even if you have an identity, without you registering yourself with MSP, you can't access the network. So second one is, if you don't have identity, your MSP can't even provide you access. So what MSP structure typically looks like? So it has the following structure, like it maintains the what are the certificate authority certificates. Why this is important? Because somebody, a new user is communicating with me, I being a peer or ordering service. What can happen is I need to know whoever is issuing that certificate to that specific user. If any random certificate authority is issuing, I don't accept that identity in my network, right? So I will accept the identities which are certified by a prescribed certificate authority for my channel. So who is that prescribed certificate authority? I know it and I will maintain it. So everybody can see for this channel who is the certificate authority who is prescribed. So only the any user needs to communicate with that certificate authority and get their certificates issued. Only then they can communicate in this network. So that is very important step. So second thing is intermediate certificates, as you know it. So this is for a hierarchy of certificate authorities. Admin certs, who are all the admins who are capable of having access to the peer. So this is admin certs. Key store. Key store is, as I said, for every role, right? There is any peer also. There is this private key and public key. I have a certain digital certificate. I have a public key and private key. So that private key is kept in the key store. One important point to note here is that the fabric actually can be communicated for identity purposes with for additional extended security, right? They can work with hardware security module, so they can make use of this specific module called HSM, hardware security module. If you are accessing the hardware security module, your security is enhanced because you each time you will get a new private key that is managed by your HSM. That is a physical device which is issued to you, and you use that. It's like in transactions also nowadays we know, right? You can have the access to a specific device which generates one-time passwords, which are only local to you. You generate them on the spot and use it in your transaction approvals, so that nobody else will be able to tamper any of your transactions. So it is similar to that HSM module. If you are using, then key point to note is your key store private key will be empty. So you will be feeding the private keys from HSM module every time you need it. So the next thing is signed certificates. These are all the public keys which are fixed. Then TLS certificates in the transport layer. If at all you want to encrypt your messages for or if you are communicating over unreliable channels and you want to communicate your messages, then you will use TLS certificates. And similarly, TLS intermediate certificates. And there is something called operation certificates. This is a fabric feature, additional value added functionality you don't need to worry about. So uh, now that we looked into the protocol and the different components used, how do you exactly configure and start the ordering service and other network services, right? This we will see in the next session in some time in a hands-on session also. But these are all the different steps. The first and foremost thing is ordering service. So you have an ordering service configured uh, to start your network. So you create the ordering service component details. Then you need to configure and start who are all the endorsers and committers of your network. You specify this information. This is the second step. You will need to start any node. While node is getting started, that role is associated. How the role is associated? You specify in the identity and in the MSP appropriately that I need to have this specific role in this channel. So that's how you will bind a role with a node. But as long as all these are all same types of nodes, it is the same code that gets executed. Once nodes are up, then you associate your chain codes with each node. So that is done as part of the next step, install chain code. Then you create the channels. So when you create the channels, what you typically do is you specify who are all the members of a channel. That is one thing. Second thing is what is the endorsement policy on that channel, right? So that is very important. So on this channel, out of these members, who can endorse your transaction? So that is the endorsement policy specification. So that is also mentioned. The next thing is the individual peers join the channel. So this information in the create channel. So this is called a special transaction called configuration transaction. So this is maintained with the ordering service, and once this is configured, then the peers with appropriate roles can join the channels. So in this example, we can see that there are three channels: yellow, blue, and red. And in the red channel, who are the participants? E0 and E1. In the yellow channel, E2 and P3 are participants, and P3 is only committer. E2 is the endorser. So that means that in the yellow channel, whichever is the transaction that gets submitted, it has to be endorsed by only E2. Whereas in the red channel, based on the specification in the endorsement policy, one of E0 or E1 or both can be endorsing any transaction. So that is part of endorsement policy. Whereas yellow channel here, E2 needs to endorse for every transaction. Otherwise, there is no endorsing peer. No transaction can get added to the network on this channel. So similarly, on the blue channel, we have all four peers part of the blue channel: E0, E2, E0, E1, E2, and P3. All four of them are part of the blue channel. So this, as I said, a peer can be part of one or more channels, and there can be multiple peers part of each channel. So all this will be configured in this way. So next one is instantiate chain code. So the chain code, whatever is there here, is instantiated on the peers. As I said, only after instantiation, the endorsement for of the type of transactions can happen by the endorsing peer. So here, if you see E2 in the peer, only chain code B is instantiated. So that means that you cannot submit any transaction of type A and E2 can execute. That is not possible. Only transaction types of B can be executed by endorsement peer E2. So similarly here, E0 can execute only smart contracts of type B. Next is yeah, so we are almost end towards jumping into the lab session. We'll take 15 minutes break and come back at 4 o'clock to go over the lab session. So I will stop for any queries if you have. Otherwise, we'll meet at 4 o'clock.
Participants, you can unmute yourself and ask the questions if you have any. I guess we do not have any questions as of now, sir. We'll take a break of 15 minutes, sir.
Sure, sir. I will come
Yes,
back
sir.
at 4 o'clock. I am disconnecting now, sir.
Yes, sir.
Session.
Yes, sir. Okay, sir. Thank you. Krishna sir?
Hello, sir. Yeah, I'm
Yes,
here.
sir. With your permission, can we start, sir?
Yeah, sure, sir.
Yes, sir. Please. Okay, I welcome Krishna sir for the third session of the day. I believe it is going to be a hands-on using a Hyperledger Fabric. Over to you, sir.
Yeah, okay, sir. Thank you. So I will share my environment. You can see my screen, right?
Yes, sir. It's visible, sir. But
Okay.
it would be helpful if the size of the character or the font
Okay,
size is
font
increased.
size.
Yes.
Okay,
Yes, sir.
okay.
Yes.
Should we find it?
Yes, sir. This is fine, sir. Thank you,
Okay.
sir.
Okay, so welcome back. So let us go over the lab session. By the way, I have a hard stop at 5 o'clock. I need to jump onto other meeting, so I will be stopping at 5 o'clock. So I will accordingly plan. The second thing is that the lab session, whichever we are going to see here now. Hello, can you see my screen? Somebody
Yeah.
else is
Uh,
sharing.
I think by mistake somebody else has projected the.
Okay, okay, sure. I think I'm projecting it back,
Yes, sir.
presenting.
Yes, sir. It's
So
visible,
we
sir.
can see. Yeah.
Yes.
So if you see the different network configurations, right? There are a set of Hyperledger Fabric sample codes available at this GitHub location, and also there is a detailed process using which you can actually set up this network. So whatever I'm going to do, uh, I'm not exactly sure whether it will be catering to all the individuals with experience of working with Hyperledger Fabric, right, with various levels of working experience with people maybe here. So I'm assuming that you can always go back to these links and which will provide very detailed steps of how to set up the network, what are the dependencies that you need to install, ensure that before you start the network and so on. So I have also taken from these locations, and even if you Google it, simple Hyperledger Fabric sample applications, you will unearth these locations. So with that, I will let me jump onto the lab session. Okay. So the first thing we see here is that you need to set up some binaries. So one thing is that so these are all config txgen transaction generation and cryptogen discover and so on. These are all different utilities that you need as part of executing different applications. Not everything may not be needed. For example, ID mixgen we don't need for our application and so on. So similarly, order and peer, these are all the applications base applications which are acquired by. So peer represents what is the role of a peer, that is mimicked by peer, and what is the role of orderer, so that is exercised using the orderer service. So these applications, some of them are important and some of them are optional, but however when you set up your environment, you ensure that all these binaries are in place. That's one thing. And you need to set up the other things like if you see there are two things, go path and go route. Uh, by the way, I'm using Go language libraries for experiencing this experiments, but I believe in the recent releases there is Java support also. The same thing what we are doing in using Java language also you can do. But Go is from beginning it is supported, so I'm using Go as the default choice here. So another thing is this environment variable Go root. What it does is it will have the Go binaries, language binaries, Go language binaries installed in this path, and it will be referred. Similarly, Go path will contain the Fabric source directories there. So those things you have to appropriately set up. So once you set up and Fabric samples you can download, there are a bunch of examples. I am going to the one example called first network. So if you see this first network, uh, there is a script blockchain first network. If you run this, you can see that these are the different options for it. You can generate the identities, certificates, and all using BYFN generate, and up is to up your service. Uh, Before I make this up, I can yeah. Before I make this up, I want to show you that there is no container as of now. So by the way, the network actually the different members of the network, either it is ordering service or peers or endorsing peers, everything we will create as a container in this environment, and they will form a virtual network, and in that network they will communicate. So that's how the network will be used. So if I just run byfn up, will do a different set of things. So it is creating initially something called the certificates and all, and then it is creating something called Genesis block, which is the first block in the blockchain network. So as you know, every block will have hash of its previous block, right? So what happens to the first block? First block has no previous block. It is the number one block. So for that reason, we have something called Genesis block. So this is deemed as the first block, and any other block will follow this. And before this, you have to generate the certificates and all. We will see these steps in detail also. But there is a single script which you run. You can see what all is happening. You can see it is taking place as a single unit. So then once the certificates, everything is created, and the Genesis block is created, there is something called configuration transaction that is created. So this is, as I said, this will be the creation of the channel itself. So who are all the channel members? Who is the endorsing peer? Who is the who can be the committing peer? So all that information we will capture in the channel configuration transaction, and that will be the first transaction that you submit to the channel to create a channel. So once that is done, um, then you will actually, so this channel transaction actually what it does is that till now your network is not yet instantiated. It will only go and update the directories in the infrastructure that you are preparing appropriately with this information. Then once you start uh, you are starting your network, then those infrastructure details are used in the process of bringing up the nodes. So here we are bringing up the nodes. All the nodes are brought up. One orderer is there, three different peers are there, four different peers are there, and there is one CLI is there. So this CLI, as I said, this is the client application, and these are all the peers, and one orderer is there. So CLI will start communicating with peers and orderers as per the protocol that we have seen. So these things we will see more closely when we are exercising one by one each transaction. And once the peers are up, what typically happens is then channel is created. First, a channel named my channel is created here. This you can see the command, specific command that gets executed. Once channel gets created, then peers will join the channel. Once peers are joining the channel, then you install the chain code. So these are each different peer is joining the channel. Hence, you see that the same command is executing multiple times. So the reason is that this is the single command which is creating the channel. Once the channel is created, then individual peers which are part of the network needs to join. So this command is executed on behalf of each peer. So first peer 0 arg1 is joining. So this is the command used. So next is peer 1 arg1 is joining. So and next peer 0 arg2 is joining. Next is peer 1 arg2 is joining. So how many peers needs to be there? How many organizations needs to be there? All that we will specify in the configuration information. As per that, the peers are created and they will be joining. So hence we see that we have total two different peers in each organization. Total two organizations. Two organizations into two peers. Total four peers are there. Arg1 and arg2. In each arg we have peer 0 and peer 1. And there is one ordering node here. So once the peers are joining, the next one is we install the chain code. And once the chain code is installed, so chain code is nothing but a Go program that we install. Then the chain code is instantiated. Once the chain code instantiated, then you can start executing any queries, because chain code is instantiated means endorser is available to process your transaction. If you go back to, if you recollect the transaction life cycle, any transaction submitted by the client will go to the endorsing peer first. Endorsing peer will execute the transaction and respond back to the client. And if it is a query transaction, that's the end. The client will directly collect the response from the query, and it ends the transaction flow. If it is a invoke or delete transaction, then only it will further submit the transaction to ordering service, right? So all that is internally is happening. First what we do, we instantiated the chain code, and then we will query the chain code for a value. We will see it in detail later. Once the querying is done, then there is a invoke that is happening. So invoke means here in this case, we are using a balance transfer example. So current balance in the account A is 100. Then there is a invoke transaction which is transferring a balance amount of 10, whichever is passed as parameter to account B. So then after the balance transfer, you query it again, then you see that in the account A, 10 amount 10 is reduced. So this can keep happening any different number of types of transactions. This is just one type of transaction. You can implement any other transaction also, and accordingly the accounts gets updated. So this is the end of it, and you can query this information which is available at the different peers. All peers will give you the same result. So that is one of the observations here. So this is the overall objective that we are going to achieve. So if I list the dockers here, these are all the chain codes. So and what are the log messages of any chain code? So there is this invoke, and the query is executed on this chain code. So you can see that is captured in the logs. Similarly, if I see another chain code, so this is on another a different peer. This is peer 0 arg1, whereas the first one is peer 1 arg2. So there is a one more invoke command that is executed. So you can see different based on the type of transactions that each one is having access to. You can see different log messages. So let me bring down the network and move into the step-by-step process to set up this network. This is just to give you a glimpse of what we are going to achieve. Now you can see none of the peers are up, everything is destroyed, your network is not there, gone. So you will start with the different. I have captured this all the commands required in one text file so that it is handy for me. I don't lose time in copying and getting these things, and also I don't commit any mistakes, right? So first thing you need to do is that if you see this command, you have to this script is actually is setting your path appropriately so that you have access to the bin. As I said, in the bin directory, here you have the peer order, all the binaries which are used in the process of network setup. So that path you have to set up to your current path, and fabric configuration path you have to set up to the current location, and all this we will be doing. So first execute these things. So this verbose is set to false because otherwise in the process of network setup there are a bunch of log messages that appear on our screen. So if you are trying first time, you can actually make verbose is true so that you can actually access what are the different types of log messages, and ensure that your binaries are there in this directory appropriately that we already have checked. Then the first step to do is that you have to create the different crypto primitives. So if you see here, there is no directory called crypto modules directory. Now what we are doing is um, we are generating the crypto config. So this will define what is my orderer organization, and my orderer organization domain is example.com. So it will come like orderer.example.com, orderer2.example.com. So this will be my ordering service node name. So this I am defining using this script, and uh, my peer organizations. I have, as I said, two different organizations, org1 and org2. So how those are coming here, we are specifying. The first organization is org1, and the domain name is org1.example.com. Under that, how many peers we have seen? Two peers we have seen, peer 0 and peer 1. So that is specified here. This template count 2 specifies that there are two peers in my network. So similarly, I have arg2, and this is the domain name, and we have two peers in that. So once this is information is captured, what are all the my ordering service nodes, and what are my peers, and how many number of peers are there in each organization, we can execute this script. So now if you see, there is a crypto config, the new directory you can see, which is not there existing earlier, got created. If you list the contents of crypto config, you will see a bunch of things here. See, it says that initially crypto config has ordering organizations and peer organizations, two directories are there. If you further dig the peer organization, you have two arg1, arg2. Because we specified in our script two organizations, it is giving accordingly two organizations. Now you go inside one organization. You have the certificates for all these different roles. Who is your CA, certificate authority, for example, right? Uh, I will see the peers, for example. What are my peers? I have two peers in each R. So each peer detail is given. I will go inside peer 0. What is my MSP? What is my TLS? That information is given. Go inside your MSP. You have, as I shown earlier, right, the MSP structure, one of the slides. These are all the admin sets, CS sets, key store signatures, and TLS certificates. All these are now you can see here part of your crypto config. Now see the key store. Key store is nothing but your key. Here you can see a private key is generated, which is used as your private key in all the communications to digitally sign your certificate. For example, if I destroy this network and regenerate a cryptogen, then you can very easily see that this key gets refreshed with a new key. So it will be automatically regenerated as a different key. So this tool generates each time a different key, right? So this is how the security is achieved. And again, what I said, hardware security module, if you are associating with this network, then you don't have a key here. You will connect to the HSM and you will invoke HSM, give me a key, and it will give each time a different key which will be used in each transaction as a different one. So now, because we have the crypto material generated, let us. So I am not going into the other materials. You can see the TLS certificates for each user. What are the peer admins for each peer admin? Again, what is the key? What is the public key? What is the private key? So everything, all that information is captured and MSPs are created. So if you dig deeper into the MSPs, you will understand that okay, who are all the network participants and their specific keys and so on. So the next one is orderers are created. We will set up the fabric configure path. So typically this has to be the path where your config tx.yaml. This is one configuration transaction I said, right? So wherever you keep that configuration transaction, that path you have to typically export to this. So in this case, actually, this is here only. It can be anywhere else. In that case, you have to set up this path to wherever this file is kept. What it is there inside this, let us see a little bit. This contains what is the ordering organization, what is its name, what is its MSP name, and where is the MSP directory inside the ordering service, right? So there is something called I said endorsement policy, right? So what are the endorsement policies? Who can who can be the readers of this network? Who can be writers? Readers means who can submit a query transaction to this network. Who can writers means who can submit a invoke transaction and delete transaction to this network, right? So similarly, who are all the admins of this network? So all this information, whatever we have discussed in theory, is encapsulated in different files here. So similarly for arg1, where is the crypto MSP directory? As I said, MSP is local to each peer and each org, right? So you have seen local MSP many places. That's why this MSP directory is associated with each entity. Orderer is one entity, so you associate one MSP with the orderer. Similarly, with each org, you associate the corresponding MSPs. So these are all different components which track who have access and so on, right? So this is one important thing. And similarly, there are many other things defined. Let me go over only the important stuff that we need for this application. Mm, so these are all application policies so that anybody can read. So again, coming to addresses, we are configuring here a ordering service called Solo. So that's why you could have seen when I do list the number of Docker containers that are up and running, you could have seen only one ordering node, whereas four peers are there, two peers for each organization. You have already seen that. So here, because we have only one ordering node, we are defining it as a solo. We have one ordering node and the ports, everything we are appropriately setting. Yeah. So other details, channel defaults. So we are creating something called consortium network. Our channel will contain participants of arg1 and arg2. Even though you can have multiple different organizations, you can limit who are all can be participating your channel. So that is what is called a consortium definition. So whoever is specified in this location, only those organization members, that is the peers of those organizations, will be part of the channel. So this is again one important thing. So notice this raft. So raft is another ordering service uh, type, so which you can configure. So all this we are not doing. So that's it. Very important things, just to recap, we are providing information about who are the consortium members. In this case, we are going with a 2 org channel. So our consortium members are any peer which is part of org1 or org2 can be my consortium member. And similarly, we have defined some endorsement policies, who can be reading and who can be writing. And also we defined what is my ordering service type. So we are using solo ordering service, which means that only one ordering node is there in my network. Hence, you can see only one container which with the name orderer. Now let me um, go and create the Genesis block for this channel. So once this information is defined in that config tx.ml, you can now go ahead and generate a Genesis block. So to do that, actually all this configuration is maintained in a specific channel which is outside of your channel, my channel that I created, right? So this, because it's a configuration information which is maintained by the only ordering service nodes, they create a special system channel called sys channel, and hence I'm creating this system channel where we execute these commands. Okay, so the Genesis block is ready. Then what we do, create channel configuration transaction. So here, the using the Genesis block, now you are going to define a channel, right? This channel is user channel. So this Genesis block can be used in many different user channels as per the channel configuration. So the Genesis block, so whatever is getting generated will be going into this channel artifacts which gets created. Just now, if you can see here, Genesis block got created, it is captured here, and so on. Few more entities will be generated as part of this exercise. They will come and sit here. So we'll create the channel. Okay, so this channel configuration is created. You can create any, give any channel name, that's up to you. I am just giving a name called my channel. You can give any name. So once that is given, there are additional outputs that are computed. This is called channel transaction. You can see here, channel TX. So this will be packaged along with the peers, and when each peer is starting, that time this channel transaction will be submitted at the time of creating a channel. So that we will see. So till now, we are only preparing the different infrastructure required for starting your peers and network, but we have not yet started any network. So once the um, channel configuration block is ready, then what you do is start the network. We have to start the network. So we did this thing. Channel transaction is done. Then start the network. So let me go and start the network. So I want to show you that till now there is no container. Only now when we are starting this network, the containers get created. You can see that different containers are up. So one of them is CLI, another one is orderer, only one orderer because of solo and different peers. So uh, when these peers are getting uh, created, how they are picking the different information that they need. So that is captured here in this another file, which is the Docker compose CLI.yaml. So this file captures information about how do you prepare your containers and what has to go inside each container, each peer. So total we have how many peers we have, 4 peers we have, and one ordering service we have, one CLI we have. So all that we will set up here, and the Go binaries also we will be copying. So all that is provided as detail here. Next one is that you can explore, but because the peers are ready, now what we will do is um, we will connect to the CLI, the client application. So to connect to the client application, because the client container is there, you can execute this command. What it says is that there is a container called CLI. Here you can see CLI. You connect to it in an interactive mode and execute the command bash. So this is what this Docker container command says. So you connect to this CLI container and execute the command bash. So you are inside that. This is the host name of the specific CLI. You can see that the host name here is matching with the container ID. So this means that you are inside this CLI container. So now being inside the CLI container, you can fire different commands to set up your channel. So what you do, first command is that create a channel and join the channel. So to create a channel, what you do is you again export inside the container the channel name. You could have actually specified this as part of the Docker Compose itself so that it is already specified, but we are not doing that because you can create any channel. If you specify inside Docker Compose, only you can create this specific channel. Now you are free to choose any channel, any number of channels you can create. So that's why you don't include that inside the Docker Compose command. Then what you do, you uh, see whether TLS is this is just optional. So this is somewhere in the configuration we have set it as true. Just we included this command. Why? Because just to ensure that whatever you have set in the script is imported as is into the peer or not. Just to demonstrate, I included this. So next is create a channel with the name my channel. So this command will create the channel. And at the time of creating the channel, what you do, you send the channel configuration transaction. So you are creating a channel, create channel, and this being your ordering service, you specify that who is your orderer. When you are creating a channel, as I said, the mandatory thing is ordering service you have to specify. That is, we are specifying here who is the ordering service. So by this time, ordering service has to be up. Only then in this process it can communicate with that. And you can see that our orderer node is already up there. So you can start your channel. That is one step. Second one is when you are creating your channel artifacts, channel transaction you have created. So that is also very important. You specify the value there, and some of the certificates required as part of this you provide appropriately. Then your channel is ready. So once your channel is there, you can join your peer into the channel. So we will execute the peer channel join command. So it already has successfully is able to join the channel. Now you can install the chain code. The chain code is accessible on this system itself at a specified location. We will look into the chain code details later at the end of this demonstration. But for now, there is on this peer, there is access to the chain code, which is chain code example 02 go. So we are using that chain code. That chain code got installed. Let us see what is the okay. I have to execute this outside of the CLI. So what I will do is I will go back here, docker ps minus a, I will execute. So you can see that now the CLI is there and the different peers are there. Till now just chain code got installed. You don't see, I will show you something actually after the chain code instantiation. Peers got joined and then chain code installation is done. Then you are going to do instantiation of chain code. So instantiation of chain code involves to specify few things. Let me explain you what else is needed. At the time of instantiation, you will specify again who is the ordering service, and also uh, you will provide in this channel what is the chain code name that you want to refer to. The smart contract, whatever is the smart contract, that is the Go program, you want to refer to as the chain code mycc in this example, and you can associate a version with it. In the Hyperledger Fabric, you can have multiple versions of chain codes running at any point in time, and you can invoke them by referring to each version. That flexibility is there. And second one is that you are passing few arguments. Here, initialization is the function, and you are setting account A to 100 and account B to 200 to begin with. And the endorsement policy is that we mentioned saying that here either arg1 members or arg2 members, one of the arg1 member or one of the arg2 member can endorse this transaction. So that endorsement policy also you have to specify at the time of the chain code instantiation. Okay, it takes a while, but eventually it succeeded. Why it takes a while? You can see now. If you see, you can see a new container getting created. So this is the container that corresponds to the chain code. So you can uh, dump the contents of logs from here. So what it is saying is that the chain code is initialized with the value of A being 100, value of B being 200. This is because these are the parameters that we used here in the initialization. We are passing value of A as 100 and value of B as 200. Hence, it is initializing these two state variables to those values and putting the log. Right. So let us do a few more commands. So till now we have done instantiation of the chain code. So now we can start doing any transaction on the blockchain network. So one transaction we want to carry out is a query transaction. So the query transaction, we want to query what is the value of state variable A. If you say that A is value 100, if you want to have B, for example, I give B, B is 200. Now, if you are curious to see what is value of C, there is no variable called C, right? So it should throw an error saying that nil amount for C. There is no specific, there is a response value 100, which says that C is not available, right? So if you give C, it will throw an error. If I give A, it is giving me value of A. So now what I will do, I will perform an invoke transaction. So what is the invoke transaction? Let me do it. So this invoke transaction, it specifies again that the ordering service is this, and in my this is on this channel, my channel, and chain code is this specific chain code. And I didn't specify the version. If I don't specify the version, it will take the latest version. And the arguments are, I'm doing invoke a comma b comma 10. That means a value of 10 I'm subtracting from account A and adding it to account B. So I do this invoke, the command is success. Now if I query a value of A, it should come as 90. So similarly, I do invoke command which does subtraction of value 15. Right? So now if I subtract 15, 90 minus 15 is 75. If I query A, it should come 75. So we are cutting the account balance from A and adding it to B. So let me query B. So what should be now contain? Because we performed two transactions, one subtracting value 10, another is subtracting value 15. So together we subtracted 25 and added to B. B is initially initialized with value 200. So 200 plus 15, 25, 225 should be there. So B value is 225. So you can now do any number of transactions here. So that's all. So we have created now one additional thing is that you can see the logs also here in the chain code logs. Whenever you are executing a transaction, initially we initialized, you see available balance of A is 100, B is 200. Now we are doing invoke. We reduced amount to 10 from this. So post that we reduced amount to 15. So after reducing amount 10, it becomes 9 and 210. After reducing 15 further, it is the value, and the query transactions are also coming. So this actually Docker yes minus a, if you see all these components are up, your network is up, and chain code is instantiated, and you are now able to fire commands into the chain code and perform this. So just before ending the lab session, I wanted to give you details about from where this chain code is getting, I mean the specific actions are coming, right? So your chain code was there at a location vi opt go source. Okay, I think let me check it once again. github.com. This is on the peer. You have access to this Go code. Okay, so the on the spear VI is not installed. So let me cat it. So this is the smart contract. Okay, so the smart contract that gets executed when we are doing any of the chain code operations is this one is the one. What we are doing, we did initialization, and whatever the values we passed two values as the arguments. Let me go back to here. Okay, so you did instantiation, and you called the instantiation function, that is the init function of the chain code. This is the init function with two variables and their corresponding initial values. So what we do in the chain code is we parse the values, and if the length of arguments is not null, not 4, then incorrect number of arguments are passed. We are expecting 4 arguments, whereas the first argument is the name of the function itself, right? So once 4 arguments are collected, we are initializing the values to A and B respectively. So we are fetching the value argA is A, value is 100. Args of 1 will be containing the value 100 that we are converting from ASCII to integer and allocating to A val. And then we are allocating the last value arg 2 is the value variable name B, and argument 3 is 200. So once we fetch these values, we are actually mentioning a val, b val as we are printing, right? That you might have seen one log message which comes after the init. It says that a value is 100, b value is 100. So it is coming from this chain code. Why it is coming from this chain code? Because we provided this chain code as the smart contract code path, right? So now you write the state to the ledger. You put the state to the blockchain ledger. You will put the variables and both value of A and B. That's the end of your initialization. So what happens when you are performing invoke? When you do invoke, a specific invoke function is called. So inside the invoke function here, what you do, you are subtracting value that is passed, whatever is the amount from account A to account B. So where it is done, so what you do, you first take the arguments A and B, and then what is the current state of A, uh, and then if A is, if you try to subtract 10 from A to B, it is good. If you are trying to subtract 10 from some C to D, where both these accounts are not there, then we will see this error. Account doesn't exist. These errors we will see. So there is some error handling that we do, and then uh, you take the values of A and B current values, and then we are subtracting directly. We are subtracting amount X from A account and adding amount X to B account. And finally, we are putting back to the state. So stub put state. So unless you do this commit put state, this change is not reflected back in the ledger in the blockchain. So it is mandatory that you add at the end. So this is what is defined as the rate set in for this transaction. So the rate set for this transaction is A and B only. X we are not using as the rate set, right? So this rate set will be A and B. So that is the end of the invoke transaction. Then when we are doing a query transaction, what we do, you pass a variable name, and that variable name value is fetched from the get state. So you will perform a get state here. So put state is you are putting the value into the ledger. Get state is you are fetching the value into from the state database. So you will get that value and print it. If you pass a state variable which does not exist, we have seen that the nil amount value is coming. So this value is coming, and this error will come in case, for example, you are executing this transaction and the peer itself is down. Then nobody can execute this transaction, right? So in that case, we will see fail to get the state. So this is if you want to simulate this scenario, you need to bring down your peer explicitly. Only then you will see this. Otherwise, if you just if you just provide a non-existing key like C we provided, we will see this error. Otherwise, if the key is valid, then you see the value of that key is getting printed on the screen. So which is done here. So similarly, there is another a function that can be done like delete, which we didn't exercise, but it is in the same line. Just if you delete the key is lost. Then you cannot use that key. So these are all defined in the smart contract, which are internal supported in the as part of peer commands there in the smart contract. So I hope that makes it clarified. So here, for example, when we are saying query A, it is querying, getting that value and printing, right? You have seen the log messages. So they are all coming from this code. So for example, logs, the corresponding logs, they are in accordance with the smart contract here. For example, query, when you do a query, we can see that name of the account and amount, how much is the amount. So this one is coming here. query, name of the account, how much is the amount. So this is coming from the specific, exact specific statement. That is the smart contract being used. So similarly, other variables, other invoke, everything else is coming from that same smart contract. Okay, so you can write your own smart contracts, and in here itself in Fabric samples, there are a bunch of smart contracts which you can use and instantiate. And by the way, so this is one way of executing the commands, right? Here we are directly going onto the CLI and manually firing the commands, which is very dangerous because if you fire some wrong command, something may go wrong. So ideally, this is not the way that you would like to handle. So what you do is there are CLIs. So then there are other examples actually here which you can explore. For example, if you want to connect to the network using a CLI, Go app CLI or Java app CLI, you can, there is a balance transfer example here. If you download that directory that I specified, so it provides a CLI where within the CLI we will be firing all these commands. So that way it is more easy to control. You don't need to manually log into the CLI container and fire these commands. So you can from your you can write the script such a way that your script actually is fired from the CLI automatically as per the script. You don't need to manually fire the commands at that moment. So that is the advantage. And here you can even do some kind of error handling. For example, if any command is failing, you want to do a retry and so on. Any type of sophisticated error handling mechanism also you can carry out. So so that's where I want to stop. There are this is very basic introductory session, right? So I wanted to give you a glimpse of how to set up the network and what are the network peers means we have seen, how to define the organizations we have seen inside the organizations, how to define your peers, and similarly what is the ordering service you chosen. We have chosen a solo, hence we have seen one order is there. We could have chosen a Kafka there, in which case we could have seen three ordering nodes being present. And internally as a client we don't interact with the ordering service except for the fact um, the transaction is being submitted, right? So otherwise transaction gets submitted, it gets added to the block, and the block gets disseminated. Everything happens. You then install the chain code, instantiate the chain code, and start firing your commands as per your smart contract. So the most important thing is that as application developer, if you are working, you will be focusing more on the smart contract. So what has to be the business specific logic that you want to implement, and what are the different other components you need to. Another important thing I want to point out is that providing the access control. Your access control to your application, blockchain application, you can do at two levels. One is your application level, layer level itself. That means you have a Java program in the front end. If you go back to my client, my slides that I presented at the beginning of today. So as an application developer, if you are writing a blockchain application, two things you will develop. One is the smart contract, which I have just shown you. Another one is the client app. The client application will be calling the smart contract functions via uh, the client module. So the in the Java application module itself, you can implement your authentication and the access control. Who are all the users of your network who can access this specific transaction or channel? So all that access control you can handle at two levels. One is at your application layer level itself. You can have a different external component which will be helping you in this process. That is one way. The second way is that inside the fabric itself, there is some concept called ACLs, access control lists. So you can use that ACL functionality also to control your um, permission to the different members of your network. So these are the two different ways. But if you are using ACL methodology, then you need to be very careful that you are applying ACL to which is specific smart contract and so on. But this is the one very nice way to provide access control to your application. Whereas if you are doing at application layer level, it is at a much higher level. And having said that, you can do it at two levels also, which is again very good. You can do access control at the application level at the same time at the fabric level using ACLs. So that is also possible. And there are many other sophisticated functionalities. You can go to Fabric homepage and see what are all the different sophisticated functionalities that are. For example, I was showing you one binary called ID mixer, identity mixer. That is one functionality which is used to submit transactions without identity. So till now we have seen that a user needs to first acquire the identity, and with that identity only the transaction is submitted. So if you see the transaction headers and all inside the block, you will know who is the user who has submitted this transaction at what time and so on. If you do that ID mixer functionality, then that is a anonymized. So there are certain applications, for example, voting mechanisms. If blockchain is used as an platform to implement voting system, online voting system, you don't want to know, you reveal which individual has voted to which party and so on, right? Which member, that has to be confidential. So how do you achieve? So that specific functionality, ID mixer is used to enable that, so that the you will have an identity. It's like your voter ID. At the same time, you will go and exercise your vote. So similarly, there using ID mixer, you will use your identity, but the ID mixer will ensure that your ID is not revealed or associated with the transaction. And also again you have to still provide all the guarantees, like you cannot vote more than once and everything else, and you need to only vote. All those things are also guaranteed. At the same time, with the transaction in the block, you don't know who is the submitter. So that's how you will provide the confidentiality, like who has provided the vote to which specific individual. So that's how that is one advanced functionality. Like that, there are many other features you can go and explore. So with that, I will stop. Shashank sir, any
Hel-
queries are there? Yeah.
uh, Participants, if you have any query, you can unmute and ask.
Okay. So if there are no
Yeah.
further questions, then thanks a lot for staying with me.
Uh,
For
Thank you, sir.
yeah.
Yeah, Krishna Suri sir, thank you for the wonderful session on Hyperledger Fabric and for the demonstration. We thank you from the family NI family for accepting our invitation and agreeing to be part as contribute as a resource person. Thank you for taking out from time from your busy schedule, sir.
Sure,
Thank
sir.
you.
Thanks a lot for inviting me, and
Thank you,
thanks
sir.
for all the participants for bearing with me for last three sessions.
Yeah.
Thank you.
Thank you, sir. Thank you. Participants, this is the end of today's session. Tomorrow's schedule will be shared by Shashank sir in the WhatsApp group. The information that we have right now is the test will be scheduled somewhere in the evening. Yeah. So confirmation will be sent as a message in the WhatsApp group. Okay. Yeah. Thank you. Thank you for kind cooperation.
Thank you.